Hello everyone, welcome to the part 2 of multi-tower modeling and seismic analysis series. And today I will show you how you can define the seismic loads for multi-tower structure and what is the actual process of doing it. Both static and dynamic I will actually explain here. So here I have made a change in the structure. Previously in the outer periphery of the podium there was shear wall, but I've changed it to column because if I provide shear wall throughout, you may think it as a underground structure, or you can say as a basement. So to make it more clear, I have used columns here. So it will be a podium like structure, or you can say a multi-level car parking, something like that. So it will be very easy to interpret the results in this case. Okay, so here first of all what we have to do, we have to separate these multi towers for the static seismic loading on the individual towers. So how to do that? Actually to do this thing, actually the process is to calculate the earthquake load manually for each tower. Now doing it manually you may find very hard, because we need to calculate the you can say floor total load of the every single floor, total weight of every single floor, and we need to find out the base shear, and we need to redistribute the base shear as a story force or story shear, right? So here I have used one trick. I have used the software itself. How to do that? If you go to here, edit, and if you go to file and export, and here you will find one option called partial etabs.edb file. So here you can export a particular tower 1, tower 2, tower 3, as we have defined previously. So you can export the tower separately. So here I have exported tower 2 and tower 3 separately, and if you see this tower 2 and tower 3, we have a different file now. Then I have fixed the base of this particular tower, and for this particular tower I have defined the static seismic load. So if I go to define and load patterns, and you can see we have the static seismic load EQX and EQY. I have used it for x direction. I have given a response reduction factor of 4. Here the seismic zone factor I have used 0.24, site type 2, importance factor 1.2, and the user defined time period, which I have used the empirical formula of 0.09 into h by root under d. So this is the formula I have used for calculating this time period here. Okay, so I have done the same for the EQY also. Okay, a simple process how we do seismic you can say loading in ETABS. So for this particular tower I have done the seismic loading, and after defining the diaphragm which we have defined in the you can say integrated model itself, and after defining the mass source here, if you see here mass source. So what I have done, I have just run the analysis, and if you see from the report, I have created the you can say project report, and if I go to the project report here, you will see that you can easily find the story forces. You can easily find the story forces for x direction and y direction, and these story forces will be using in our integrated model. Though it is not compulsory to do that in the integrated model, you can directly find out the base shear from here, because this static analysis we are doing here just to get the base shear so that we can scale our response spectrum load. Okay, so just to get the scaling factor we are doing this analysis. So you can directly get the base shear from this individual model also, but just to make the thing a bit simple, or you can say a bit the process integrated process. So I have what I have done, if you see here, I have done the same process for the tower 3 also. Okay, for the tower 3 also I have defined the loads similarly. Okay, and I have got the seismic load here from the report. You can see for x direction is the y direction force, and I have the x direction forces also, story forces. Okay, so here only I am getting the base shear, but what I have done in this integrated model, I have created two load cases. So if I go to load pattern, you can see we have EQX and EQY for tower 2 and EQX and EQY for tower 3. And I have defined this load cases, or sorry, load patterns as user load. So if I just modify this, you can see only for tower 2 X direction, I have assigned the, I can say, story forces which I have got from the individual model, right? So you can also, just to make it simple, you can click on this tower 2, so you can see only the tower 2 forces will be visible, right? Similarly, I have done for the EQY, only FY forces. In the FY I have assigned the forces, and similar process I have done for the tower 3 also. Okay, FX and FY. All these values I have got from the individual model, as I have just shown you. You can see FY. Okay, this process is the additional process. It is not required at all. Just to show you how you can do that in the integrated model itself, I have done this this process, but it is not compulsory at all. Okay, so now after defining the static load cases here, what I will do, I will just run the analysis and I will show you how the base shears are matching actually for the individual tower and the towers in the integrated model itself. You can see the analysis is done. Now I will go to tables, analysis results, structure output, base reaction, and show table. I will just filter these load cases, EQX for T2. Okay, apply. So here I have the T2, EX and EY, and it is around 3021 and 4532. So let me just go to my T2 model. This is my tower 2 model. T2 means the tower 2, and I will go to the tables here, analysis results, base shear, and here also for EQX and EQY you can see 3021, 4532. The same results we have got in the integrated model itself, right? So it should be same because we have used the forces from this model only. It should be same obviously. Now I will go to this one, tower 3, 3014 and 3020. Okay, so I will go to my tower 3, and if I show you the base reaction here, so 3014, 3014. So there is some change we are seeing here. Maybe somewhere while putting the values I have done some mistake, or I have not used some you can say numbers after the decimal. So there is still the difference is very small. Okay, the difference is very small here, so it's not an issue. So you can see how from the integrated model we can create these individual models. We can assign the static seismic load here, and again from after getting this static seismic forces from this particular model, we can apply this in the integrated model itself. Okay, so this process is the additional process. Again, I'm seeing it is not compulsory at all. So the requirement of this static analysis is to while performing the response spectrum analysis for this particular structure, we need to scale up the base shear, right? So in that case we need to have the you can say individual base shear for the individual towers. Okay, so now I will you can say click on this show undeformed shape. Sorry, I will click on this show undeformed shape here, and I will define the response spectrum load. So for that I need to define the response spectrum function here first. So I will just define the response spectrum function. I'll go to IS 1893/2016, add new function. IS 18. Okay, I will just write RS response spectrum. I will take seismic zone 0.24. I think it is for seismic zone 3, right? No, seismic zone 4, right? Okay. So 1.2, soil type 2, and the response reduction factor I have considered 4 for all, right? I'll click on OK. I'll delete this. Okay, no problem. Okay. Now I'll go to define load cases. Now similarly, I will define 4 response spectrum load cases, for 2 for tower 2 and 2 for tower 3. Okay, so I'll click on add new case. I'll write is right here RS X for tower 2, I'll modify this and I will change it to response spectrum. Here I'll click on add U1, I'll click on response spectrum and I'll keep the scale factor as it is. The diaphragm eccentricity you can use 0.05. Okay, and click on OK. I'll click on add copy of case. I'll make it RSY for T2. Okay, I'll change it to Y2 direction and I'll click on OK again. Similarly, I'll make for tower 3 also. So I'll make a copy of this. I'll make RSX for tower 3. Okay, add copy. I'll make RSY for tower 3. I'll change it to Y2, U2, sorry, and click on OK. So you can see I have defined 4 response spectrum load cases. So why I have defined? Because these 2 response spectrum load cases will be scaled up according to the base share of my tower 2, and these 2 response spectrum load cases will be scaled up according to the base share, static base share of my tower 3. And we will create separate load combinations using this tower response spectrum load cases for tower 2 and tower 3, and separately we will be creating you can say performing design for the tower 2 and tower 3, and then we will go for the podium. Now the complexity we will be having in the podium, because in the podium the process is not very easy. We cannot design directly using any of these load cases. So in that case we need to create the envelope, which I will show in my next video. So I'll click on OK now. Now I will perform the analysis again. Now it will take some time to finish the analysis. Okay, so the analysis is complete. Now we need to find out the multiplication factors, right? So I'll go to tables, analysis and results, structure output, base reaction, show table. First let us go for the tower 2. So I'll click on this EQX, EQY for tower 2, and response spectrum X and response spectrum, sorry, not this one, EQX, EQY for tower 2, RSX and RSY for tower 2. Apply multiple item filter. So here we have got EQX by spec X, you can see, sorry, response spectrum X, we have named it here, right? And then EQY by RSY, right? So these things we need to write actually, so that we can apply it in the scale factor. So 3021.8335 by 2090.6506. Okay, and then I will write EQY by RSY. So it is, I'm just writing in my note so that you can also write it here and you can apply in your model if you are doing it with me. So it will be 4532.7505 and 1884.5628. Okay, similarly we will do for the tower 3 also. So I will just click on this, right click here, output case, and I'll click on here EQX for tower 3, pressing control I'll press this one, EQY for tower 3, RSX for tower 3 and RSY for tower 3. Apply. Similarly, we'll write from here also. So I think the values are pretty similar. No, here there is a change actually. So let me write again. EQ x by RSX. It is by 3014.5958 by 2090.6506, right? Similarly, for EQY by RSY, so it is 3020.5958 by 1884.5628. Okay. So now let us click on done here, and I will go to my load cases. Okay, for tower 2 response spectrum X, and I will multiply the factor here. So it was 3021.8335 divided by 2090.6506. I'll press enter. So I got the scaled you can say response spectrum here. I'll click on OK. I'll go here. I'll multiply with this again. So it was 4532.7505 divided by 1884.5628, right? 5628. I'll close the bracket, and so I got the scale factor here also. Similarly, I'll do for the tower 3 also. So it will be multiplied by 3020.5958 divided by 2090.6506. So 2090.6506. I'll close the bracket, enter. Okay. Similarly for y direction. So this is the only reason we have done the static analysis. So this Bayesian values you can find out from your individual models also, right? So it is 3020.5958 by 1884.5628 1884.5628. Enter. So we got the scale factor here. Click on OK, and run the analysis again. So the analysis is done now. So you can see in the tables analysis results, structure output, and if I show you the Bayesian, I'll only select this earthquake loads and my dynamic earthquake loads. You can see it is matching nearly. Okay, 30, it's not that different. EQX and RSX-T2, EQY and RSY-T2. Okay, EQX-T3 with RSX-T3 and EQY-T3 with RSY-T3. So it is matching a bit. Now click on done. You can save it here. You can also see the deformed shape. So if I show you this show deformed shape for RSX T2, you can see that only the tower 2 will be moving here. Okay, RSX YT2. Okay, So now, as it is a dynamic load, so it is not for a particular you can say structure. It is affecting the whole structure. But if you see the static one, if I show you the EQX T2, it will only show you you can say displacement or deformation in the tower 2 only, because we have assigned the force in the tower 2 itself. But when it is dynamic analysis, in that case it is affecting the whole structure, right? So in these cases, obviously we have to perform the dynamic analysis, and the purpose of you can say performing the static analysis is just to you can say scale up the base shear. Okay, so this is how we should actually define the seismic load cases for these models having multi towers. And you can say if you have a common podium, so you can define the seismic load like that. So in our next lesson, I will show you how you should create the combinations and how you should perform the design for different towers, including the podium. Okay, so this is it for this video. If you like it, please give a thumbs up here, and please do share with your colleagues so that they can also watch this video and they can also learn from my videos. Thank you, and we'll see you in the next video.